known as bridge engineer, PhD in structural engineering, having more than 25 years of professional experience, particularly in engineering projects covering mainly highways, bridges, ROP and flyovers. This includes conducting site investigations, hydraulic calculations, fixing of span arrangements, preparations of preliminary and detailed designs, proof checking of bridges and preparation of working drawings for all components of the bridges. The experience also embraces preparation of preliminary and detailed cost estimates, preparation of tender designs and drawings and technical proposals for prospective projects. Conversant with all relevant Indian codes of practice, namely IS, IRC, BS and ASHTO, familiar with modern methods of construction of bridges and possesses wide experience in design and construction of beam foundations. Expertise in bridge design include long span structures like cantilever bridges, cable stayed bridges and externose bridges. Well versed in fast track construction techniques such as precast segmental construction and has been recently associated with prestigious projects of highways, flyovers, metro viaducts, etc. Also have experience as team leader for different type of highway bridge projects like pre-feasibility, detailed project report, pre-bid detailed design, and gathered experience in planning, project preparations and design of many highway and bridge projects. Sir, we welcome you to the session, sir.
Good afternoon to all of you. Am I audible? Am I audible?
Yes.
So thank you very much for the nice introduction. And today I am here to just discuss about one particular project which we did it in Patiala. So Patiala, in the state of Punjab. Patiala Byepass we did one highway project. And in that highway project, which comprises of many structures, including steel bridges, the concrete post tensioning bridges, slab bridges, box bridges, and so many other types of bridges in that stretch. So, among all those bridges, one of the bridge which was of very much importance was a steel long span bridge, steel bridge, which was constructed across the Bhakra Canal. Bhakra Canal is a huge canal with a wider base bed, and the flow of water in the Bhakra Canal is too high in the sense that the velocity of flow of water is in the order of about 5 meters per second and more. And if we just look at it, we will be afraid of just going near to the canal. So, such a huge flow will be there during peak during the monsoon season, whenever there is a peak rainfall, high floods will happen. That time, the huge water is released to the canal, and the canal is fully flowing with the huge water. So, under such circumstances, we were supposed to do a rehabilitation work of a particular bridge, and this bridge was a steel bridge. That too, it was a through type bridge. There are two types of bridges basically. One is a through type bridge, the other one is the deck type bridge. The deck type bridge means on top of the deck slab, the vehicular movement, the traffic will be happening on top of it. Below there is a structure. That is called as the deck type. In case of through type bridges, the superstructure, the major part of the superstructure will be above, and the traffic movement will be happening at the bottom of the structure. That is called the through type bridge. So one such bridge, it was just 60-meter long span, single span bridge, 60 meter from one support to the another support. So it was an old bridge, and we were supposed to rehabilitate that bridge because of two reasons. So in this bridge, what all we did, how we have come about, and what are the design intricacies that were involved, and how we have done it. So it is a case study. So I thought I will share this information to you all. So the presentation will be in this particular fashion. So first definition, history, and second is design aspect. What are the designs aspects are there? What are things we need to consider while designing the new bridge as well as rehabilitating the bridge. So in this case, there are two aspects. One is the rehabilitation of one existing bridge. Another bridge which is very parallel to the same bridge. One more bridge we were asked to design another bridge just side by side. So because of the heavy traffic in that area, the present bridge was not able to cater to the traffic movement, present traffic movement. So we were asked to take up another bridge and construct it just parallel to the existing bridge. So we have rehabilitated the existing bridge, and also we have designed a new bridge, and it was constructed and it was launched to the site. Means normally these type of bridges, the whole bridge is fabricated outside the bridge location. Normally whole bridge, complete bridge structure is fabricated, and it is on the bank of the river or bank of the canal, is before the actual site. So once every construction is completed, the whole bridge is moved toward the other side, and launching, what we call this, launching of the bridge, they will do the launching, and we did it, and it was made to sit on the pre-designed supports. They are called as the abutments in this case, because only two supports are there. Two extreme supports, they are called as the abutments. In between, if there are some supports, we call it as piers. In this case, piers are offset because it's a single span bridge. Suppose if it were to be a multi-span bridge, then you would have got number of piers also. In other bridges in the same Patiala Byepass, we have designed the multi-span bridges, but in this case, we got only a single span bridge, 60-meter long single span steel bridge. So construction process, how it has to happen, and then fabrication detailing, what are the intricacies that are involved, how to design the different elements, and how to fabricate it. And so many complications are there in the design, and fabrication also there are so many complications. We need to take care of those things. And erection and launching. So now the definition of a bridge, and then reason for the rehabilitation of the bridge, and what is the history behind it, and what are the current practices that are there in the industry. So what is the practice that is available to us that we need to consider while designing as well as while executing. Coming to the considering all these things, we prepared a drawing which is comprising of the existing bridge as well as the new bridge. Now in this case, the top one this portion, this is the existing bridge portion. So this long span, 60-meter long span bridge is this one. This is a 60-meter span bridge. There is another bridge here, small stream was running, and this is another bridge, another parallel, one more stream was there. And these two bridges also we designed. This was a concrete bridge, this was also another concrete bridge. But this one is a steel bridge. The steel bridge, fortunately, the width of the bridge was 12 meter, and there was no problem for it, for a two-lane bridge. Two-lane means two traffic lanes. Normally the width of two-lane bridge will be, the traffic lane width itself will be nearly about 7.5 meter. And total overall width of the bridge will be about 12 meter, considering the footpath, considering the crash barrier portion, everything. The total width will be about 12 meter. That is one bridge. So the width of the bridge is 12 meter, the length of the bridge is 60 meter. Here there is a support and here there is a support. So the two supports and a superstructure. Below there is a substructure. Substructure, this is the substructure that we provided. It was already there, we strengthened it. This means one support, this another support. Normally it is called abutment support. But in this case, since it is a support here, another bridge just beyond this point, another bridge is also there. So we went in for a different type of support here, and it is a abutment pier, abutment and pier. So we provided different type of support here, and this is an abutment. And the arrangement, steel bridge arrangement. This is the steel truss. The length of the steel truss is this much, 60 meter. From here to here another extreme steel truss will be there, and this is the elevation of this is the elevation. And the traffic movement will happen at this level. So it will happen at this level. Here, see here, there is a concrete PSC kind of bridge is provided here, and the another PSC the bridge here, and there was a gap, and it is connected to a gap, small slab bridge. Okay. So now this is the scenario we just considered. Now the new bridge that we proposed was adjacent to this bridge only, parallel to this. So here, this is the same view, this foundation view, and this is the plan view, top view. That's it. Now here you see, this is another view of the grid. Consider cross-sectional view of the grid. See, this is the truss. This is the truss. This is another truss. In connecting these two major trusses, there will be a cross-sectional element comprising of the stringers as well as the cross beams. And top of the stringers and cross beams, there will be a slab. That is a concrete slab. So put together, it becomes a composite structure. So this is a composite structure. Now this whole thing about 8 meter high, because it is a through type grid, naturally the height of the grid truss should be more. Then in this case, the height is 8 meter height truss is provided. Connecting the top of the two trusses, there is an element here, which is the top part members. At every 5 meter or so, the bridge truss top members, top of the steel bridges will be connected by these cross members at every about 5 meter or so. Now this is the abutment pier what I said. This is the pier cap. Over that there will be a bearing here, there will be a bearing here. This is a steel truss, and the cap is in turn supported over the pier, and pier is supported over the abutment, over the pier pile cap. This is a pile cap, and this is the pile arrangement. It's a pile foundation. Normally in northern India, wherever we go, basically we are wet with the loose type of soil, alluvial soils we are waiting. So in such situations, for a structural person, it is better to go for a pile foundation or a well foundation. In northern Indian river bridges, normally people go for the well foundation only. Major Ganga bridges also well foundation is provided, and major other bridges for other rivers also. Majority of the bridges they are going with the well foundation. But in this case, we went in for a pile foundation because it was easy for us to go for a pile foundation in this location, and also it was on the bank of the canal, so we could do the piling easily. So that's why we just went in for the piling. But in case of river bridges, it may not be the same case, because in case of river bridges, in alluvial soils, the deep foundation means it has to be a well foundation, like sinking of well and other things, pneumatic foundation, well foundation, we go for such type of thing. So this is the pile foundation, pile cap, and pier is there, pier cap is there, over the pier cap, the whole superstructure is set. And in this place, there is a pedestal here, this is the pedestal, and I think you can see here, pedestal. And over the pedestal, our bearings are bridge bearings. But in this case, in our bridge, we provided a part-cum PTFE bearing. So what is part-cum PTFE bearing is? It's a steel bearing. It will move horizontally. It will be in a fixed condition. It will also rotate. It will move in horizontal direction as well as in the transfer direction. So those type of bearings, they are called part-cum PTFE bearings. So by part-cum PTFE bearings, 2-3 types are there. One is fixed bearing, another is sliding bearing in the transfer direction, sliding in longitudinal direction, and free bearing. Free means it will move, the movement will be there in both directions, x and y direction. The movement of the whole bridge will happen. So why the bearing is required for a bridge? If you ask me, so bearing is provided in case of a bridge to transfer safely the